All right, hello class. Today in this video, I just want to quickly go over how to solve the z-score and probability questions from the homework. Now, obtaining and calculating a z-score is relatively easy. However, finding out the probability from one score to the other may be a little bit more difficult, but we'll work through it. Hopefully by the end of this video, it'll be easy. And you'll have no problems. So let's just get into our example right here. This question is very similar to question 1 from the homework. It says a standard normal distribution has a mean of 20 and a standard deviation of 2. What is the z-score for a score of 25? Now, to solve this problem, all we need to do is use the z-score equation in the textbook, right? It's z equals x, which is the observed score, minus the mean divided by the standard deviation. So plugging our values in, we have 25, which is the observed score that we want, minus 20, which is the mean, divided by 2, which is the standard deviation. Doing the math, this gives us a z-score of 2.5. So given these population parameters, a mean of 20, a standard deviation of 2, a score of 25 will equal a z-score of 2.5. Now, that simply means, right, that the score of 25, again, given these population parameters, a score of 25 deviates from the mean, right, by 2.5, right, deviations. I'm going to say that again, right? This 2.5, this z of 2.5, will let us know that a score of 25 will deviate from the mean by 2.5 standard deviations. Let's go over here and look at the standard normal distribution that I've crudely drawn here, just to give you a visual. So this is our mean of 20. We have a score of 25, right? That z-score of 2.5 is right here. So that just lets you know that a score of 25 will deviate 2.5 standard deviations from the mean. That's all that means. All right. Just to give you some context around and understanding around what that z-score means substantively. Now let's do the probability part of this right now. So what if I ask, what is the probability of obtaining the z-score this high or higher? Now, to answer this question, we'll use table A from the back of the book. So going to table A in the back of the book, we see here that it is the percentage of area under the normal curve, right? So let's look at our normal curve. Table A simply just shows you the percentage areas from one z to the next, from one z to one point to another point in the normal distribution, okay? Now, to use table A, we will need to understand 3 things. These columns right here, column A, column B, and column C. Column A is simply the z-score that we want to identify. Column A gives us the z-scores that we need to identify. Column B is the area between mean and z. Column C is the area beyond z. Again, let's go to our standard normal distribution here just to give you a sense of what that means. So column B is simply from the z-score to the mean. Column B, simply that area right here, from the mean to the z. Column C is from the score to the end of the distribution. So it is the other side of the z, right? Simple as that. And that is what these 2 columns shows us. Now, let's go to our probability question here. So really what we want to know is, what is the percentage area from 2.5 and beyond, right? From 2.5 to the end of the distribution, okay? To do that, first we need to find our z-score of 2.5, looking in column A. That's not it. That's not it. Here we go. 2.5. That's column A. We scroll down. We find the z-score of 2.5. What column do we need to look in? We need to look in column C because that will give us the area from that z and above. That percentage area is 0.62. So that means the percentage area from 2.5, a z-score of 2.5 and above, is 0.62%. So that means the probability of obtaining a z-score of 2.5 or higher is 0.62%. Easy as that. All right. And then we can even connect it to the score that we were observing, which is 25. We can then say, given these parameters, a mean of 20 and a standard deviation of 2, right? Obtaining the probability of obtaining a score of 25 or higher is 0.62%. Okay? Now, let's make it a little bit more difficult, just a tad. What if I ask you, what is the probability of obtaining a score between 19 and 25? To answer this question, first we simply need to calculate the z-score for each one of these observed scores, 19 and 25. Let's do 19 first. Using our z-score equation, we get z equals 19, which is the observed score we want, minus 20, which is the mean, right? Divided by 2, which is the standard deviation. This gives us a negative 0.5. So the z for 19, given these population parameters, is negative 0.5. That's the first z. Then we need to do the second z, which is 25. We've already done that math. We know what that is, but we'll just do it again. So z equals 25, which is the observed score, minus 20, which is the mean, divided by 2, which is the standard deviation, equals 2.5. So a z for a score of 2.5 is, a z for the score of 25 is 2.5. So we have our two z-scores. And so really what we want to know is, what is the percentage area between a z of negative 0.5 and a z of 2.5? To answer this, again, we'll go to table A. The first part is that you need to find the area for negative 0.5. But first, before we do that, I just want to give you a visual of the area that we need. This will then determine, and this will help you determine what column you should be looking in to calculate the percentage area. Now, so we said we want a z-score of negative 0.5, right? This is below the mean. Since it's a negative, it is on the left side of the normal distribution, right? So a z-score of negative 0.5 would be somewhere right here. We've already stated that our z-score of 2.5 is somewhere right here. So if you can just visualize this, this whole area is really the area we are concerned with for this problem, right? Negative 0.5, right? This is our mean, right? To a z-score of 2.5. This whole area from negative 0.5 to the z-score of 2.5. And as you can see, I've just plugged in the real observed number so you can see as I place the actual population parameters on the normal distribution. Here's our mean of 20. Here is our score of 19. And here's our score of 25. So this is the area that we are concerned with, the negative 0.5 to 2.5. To get the area for negative 0.5, first we need to look up a z-score of 0.5. So that's not it. That's not it. Here it is. Again, using column A, we can find the z-score that we want. So here, a z-score of 0.5 gives us an area of 19.15 from the z-score to the mean. Why do we want the area from the z-score to the mean? Because again, look at our diagram here. We want the area from that z-score to the mean, right? We don't want the area from here to here. That will be from the area from that z-score to the end of the distribution. That will be column C here. Here we want column B because we want the area from the z-score to the mean. Thus, we have an area of 19.15. Now, let's do our second z-score, right? We want a z-score of 2.5. So using column A, we go down, we locate the z of 2.5. Here, we want to use column B again, the area between mean and z. Why? Because we want the area from that z-score to the mean, the in-between, okay? The in-between from the z-score of 2.5 to the mean. So this is the area we are concerned with, column B. So that gives us a percentage area of 49.38. So let's just visualize this. From negative 0.5, we have an area of 19.15, which we just located. This is the mean, right? And from the z-score of 2.5 to the mean, right, we have, which we just looked up, 49.38%. So these are the two percentage areas that we are concerned with, 19.15 and 49.38. This whole area combined is the area that we are concerned with. So we need to add them together. So 19.15 plus 49.38 gives us a total percentage area of 68.53. Therefore, we can say the probability of obtaining a score in between the scores of 19 and 25, given these specific population parameters, is 68.35%. So if you have any questions, please contact me, and hopefully I can clarify anything you may have been confused about in this video. All right.